1, 2, 3, My baby don't mess around because she loves me so, and this I know for sure. But does she really wanna?
Here's a function, f of x equals x squared times x to the third. If I want to take the derivative, well, you know what I could do? I could just simplify my function, which would probably be the easiest thing to do, is f of x equals x to the fifth, and take the derivative. And using the power rule, I'd be done. However, later on this year, we're going to be seeing functions that it might not be all that easy to simplify first. So we're going to talk today about something called the product rule. The product rule is another shortcut rule, kind of like the power rule, that allows us to take the derivative of functions that are expressed as a product, meaning two things multiplied. So let's remember this. I'm just going to put it off to the side here. Well, I guess I'll just leave that there. And let's take the derivative of this function without first simplifying it. Now, in order to do this, we need to know what the product rule is. And the product rule is this. The product rule says if your function is some piece times some other piece, then the derivative of that function, this is some notation you may not have seen, that just means the derivative of a times b is going to be equal to the derivative of the first part of the function times the second part of the function as it is, plus the derivative of the second part of the function times the first part of the function as it is. That's the product rule. And again, the product rule is this little kind of shortcut rule that allows us to take the derivative of a function that's expressed as a product. Let's try it here. So I want to take the derivative of f of x. So I'm going to take the derivative of the first part of my function. So the derivative of x squared is 2x times the second part of the function as it is, plus the derivative of the second part of the function, so the derivative of x cubed, which would be 3x squared, times the first part of the function as it is. So far, so good? And there's my derivative. Now, of course, I can clean this up a little bit. Let's just go ahead and multiply and simplify. 2x times x cubed is 2x to the fourth. 3x squared times x squared is 3x to the fourth. Those look like the like terms to me. So I have 2x to the fourth plus 3x to the fourth, 5x to the fourth. And there is my answer. Hey, is it what I got doing it this way? Yes, it is. Yes, it is. I know what you're thinking. You're thinking, why in the heck would I go through all of this work using this product rule, but I can just simplify first and take the power rule? And the answer is, by all means, do this. However, we need to be practicing the product rule for later this year when we get weird functions. For example, if my function, and don't freak out, we're not doing this right now, but if my function, let's say g of x, was something like x squared times e to the x, that's a product. That's x squared times e to the x. I can't simplify that very well. In fact, I can't simplify that at all. If I needed to take the derivative of this, I would have to use the product rule. So we're not going to do this type of problem quite yet, but we are going to be practicing the product rule as we did right here.
I'm going to do one more of these examples, if that's all right with you, Ms. Stewart. So here I have another product. It's something times something, and I want to find the derivative of it. So I'm going to call the first guy A. Okay. Call the second guy B. And I know the basic rule. When you take the derivative of a product, it's just the derivative of one of the guys times the other guy plus the first guy, not the derivative, times the derivative of the second guy. So I mean, I'm just gonna, I could write it out here. I like to think of it as A prime B plus A B prime, and I think Ms. Stewart, you write it as A prime B plus B prime A. The order doesn't matter.
It absolutely doesn't.
It's the same thing.
Absolutely.
And I just do it this way because this is, I say it to myself as I write it. I say the derivative of the first guy, 2x minus 5, the derivative is just 2.
Beautiful.
Times the second guy, 7x minus 1. So I just copy the second guy exactly as it is, plus the first guy, 2x minus 5, times the derivative of the second guy. And again, I'll just use the power rule here. So this is 2x plus 7, and of course the derivative of -1 is 0, so I don't write that at all. So again, I just think about it as derivative of the first guy times the second guy plus first guy, derivative of second guy.
Beautiful.
That's the whole thing. What could be easier than that?
What could be
There's
easier?
nothing really. Of course, at this point, I could multiply this all out, and distribute this whole business, and combine like terms. And at some point, we might ask you to do this. But for right now, I'm just taking the derivative and leaving it just as it is. And the other thing is, of course, Ms. Stewart, I would get the same answer if I took the original guy, multiplied it all out, and then took the derivative of that. Of course, you're going to end up with the same answer in this case. You've seen the product rule, and I bet you're wondering how you take the derivative of a quotient, something divided by something, right? And it's actually a fairly similar type of rule. The quotient rule is just A prime B minus AB prime over B squared. So I'm going to use the quotient rule to find the derivative of this function, and then I'm going to justify it by first simplifying it and then taking the derivative. So I'm just going to follow the rule. It says, now of course A is the top and B is the bottom, so it says A prime, which is the derivative of the top, right underneath. The derivative of the top, 5x to the 4th, times the bottom, minus, following along, Ms. Stewart?
I am.
The top, it's just x to the 5th, times the derivative of the bottom, that's the bottom right there, all over the bottom squared, b squared. So I have x squared squared. Well, I mean, I could just leave it like this. This is really the derivative, but let's see if I can simplify it a little bit, shall we?
Let's do.
So I have 5x to the 4th times x squared, right? I'm just adding exponents here, so that would give me a 5x to the 6th, right? I'm just adding the exponents. Minus, this is a 2x to the 6th. Interesting. X squared squared, that's of course x to the 4th. And I think I can simplify this even a little bit more. This 5x to the 6th minus 2x to the 6th is 3x to the 6th over x to the 4th. I think I can keep going. What do you think?
You can.
I think I can get rid of 4x's down here,
Right.
4x's up here, and I am left with 3x squared. And there you go. That is the derivative. So we should probably, just to make sure this actually works, we should probably see if in fact that is the derivative of this function. What if I simplify it first? Well, if I get rid of 2x's on the bottom, 2x's on top, I end up with x cubed, and the derivative of x cubed is 3x squared. I think it works.
I love this
I
math
love when
stuff.
math works out.
I know.
It's great. All right.
So why, Mr. Haas, if you could just take the derivative so easily there by simplifying first, why do we have this quotient rule?
Well, that's an excellent question, Ms. Stewart.
Thank
In
you.
a moment, we're going to see an example where you can't simplify first.
Here's a nice rational function. So I have a quotient, right? one piece being divided by the other piece. And I think you'll agree that you cannot simplify that very easily, or actually you can't simplify that at all.
Yeah.
You can't simplify that.
Can't be simplified.
So the only way to take the derivative, well, that's not entirely true, but a good way to take the derivative is to use the quotient rule. So let's do that. And again, we've got our little quotient rule here. This is something you're going to have to memorize. We don't really memorize a lot in this class, but that is something you'll have to memorize. A, of course, is my numerator, and B is my denominator. So here we go. Taking the derivative of my function. So I'm just going to follow here. The derivative of the numerator, so I'm using my power rule there, is 2x minus 0, times my denominator as it is, 3x plus 2, minus my numerator as it is, don't forget those all important parentheses, times the derivative of the denominator. Derivative of 3x plus 2 is going to be 3. All over your denominator squared, 3x plus 2, quantity squared. Now, I could leave it like this. This is the derivative. I might sometimes ask you to simplify this further. So again, sometimes you can just leave it like this. Sometimes we'll simplify it. Let's just simplify it for old time's sake. Simplifying usually means just you multiply what you can multiply, you add what you can add. If there's any dividing you can do that. So I'm just going to combine that numerator, do some distributing. 6x squared plus 4x. Let's see, I'm going to think of that as a minus 3 that I'm distributing through, so negative 3x squared plus 15. Did I freak anybody out there?
No, I'm good.
Good. All over 3x plus 2 squared. And let's come on up over here. So combine like terms. I've got some x squareds, 3x squared it looks like, plus 4x plus 15, all over 3x plus 2 squared. And it's kind of considered to be fine not to expand that denominator. You can just leave that as 3x plus 2 quantity squared. I don't think there's anything else I can do to simplify that further. And so there would be the derivative